Hi, my name is Kylie and I'm doing part 1. So these are the solutions that we were given. Here I am showing you a chart that has our volumes delivered as well as our dilutions and how to calculate volume delivered. So the formula for that is volume final minus volume initial equals volume delivered. So for our first solution, it's 9.80 minus 8.69 equals 1.11. And so for all of these solutions, I plugged it into the same formula. Then on the bottom, we have our dilution formula, which is M1 V1 equals M2 V2. So for solution 1, that would be 63.55 times 1.11 equals M2 times 50.00. And then that would be 70.54 equals M2 times 50.00. And then you divide out the 50.00. And that gives you 1.41 for M2. So I inserted all of the others into that same formula.
Today we're constructing Beer's law plot, which is found by absorbance over the concentration. And the absorbance, which is measured in nanometer, and that one is plotted on the y-axis, and concentration, which is in molarity, and that will be on the x-axis. And we have the absorbance from the table given to us, and we find the concentration by multiplying M1V1 equal M2V2, and we find M2, which is the unknown concentration in molarity. And after that, we start plotting the absorbance, the concentration on the x-axis and the absorbance on the y-axis, and that will give us the equation y equals 0.164x plus 0.075. And once we find the concentration, we will be able to plot the line. And we see here some points are out of the line. This could be solution have different absorbance, or it could be an error in measurement. And that should be all about finding the Beer's law plot. Thank you.
My name is Liliana Maximiliano, and I'll be doing part 3 of the Beer's law plot lab. So, you ready? So, if you look, if you look at the graph and you look at the line of best fit, if the linear equation it gives you is y equals 0.164x plus 0.075, and so you just want to plug in the site A data and then the site B data. So y equals 0.164 for site A. You put 0.140 plus 0.075, and that will give you the answer of 0.0979. And then so for site B, you would also do the same thing. So for site B, y equals 0.164, and then you plug in 0.262 plus 0.075. And so for the answer for site B is y equals 0.118. So it shows that site B has a higher concentration of copper according to the calculations from the linear equation. So we recommend site B for mining to the company. And that's all for my part.